Today's math lesson is lesson 5.4. It's what to do with remainders. You can see that I'm using all the colors here of the rainbow. We have red, orange, yellow, green, blue, purple. And you need to put the date up there in the empty box and pause your journal until it looks like this. All right, I just have to put this out there. This is one of my favorite math lessons. I love it because it's one of my favorite things that I like to look for when I'm solving multiplication or division problems. Excuse me, when I'm solving division problems. So we have a little thing called a remainder, and sometimes that gets phrased as a leftover. And what we get to do on today's math lesson is to look at the remainders and decide what are we going to do with them. Are we going to leave it as a whole number, like when we put a little r and then the number? Are we going to convert it to a fraction? Are we going to completely ignore it? Are we going to use it as our answer? Are we going to convert it to a decimal? All of those things are options that will come up when you're dealing with remainders. So the first thing I want to teach you is in some story problems, you will actually ignore the remainder. Okay, so we're going to write number one. One thing that you do with remainders is ignore the remainder. So I'm going to write it like this. And then I'm going to put a box around it. And I'm going to color that red. One thing you can do when you're dealing with the remainder is to just simply ignore the remainder. Let me give you an example of that. Okay, you're going to write this story problem. Miss Fisher has 3,281 goldfish. Bet you're wondering if those are actual goldfish or goldfish crackers. What do you think? I'm going to say crackers. That's probably more realistic, right? Miss Fisher has 3,281 goldfish crackers, and she wants to put them into groups of 4. Do you see the phrase groups of? Will you underline that in red? That means I'm doing division. If I'm taking a big number and putting them into groups. My question is, Miss Fish, my question is going to be this: how many groups of 4 can she make? So we know it's division. Let's go ahead and do division. And why don't we do it in the place value sections? Okay, so I have 3,284 divided by, 3,281 divided by 4. Four won't go into 3, so you put an X above that, but 4 will go into 32 8 times. But it's not just 8, it's 800. And 4 times 800 is 3,200, or 3,200. I subtract. And I'm left with 81, so I draw another place value box. Will 4 go into 8? Yes, it goes in twice. So you put a 2 above the 8. And it's not just twice, it's 20 because of that place value. And 4 times 20 is 80. Subtract. Now I have a leftover. Should I draw another place value box? No, because it's only 1 and I need groups of 4. So this is what I would call my remainder. So will you please circle it and write remainder? So my question is, how many groups of 4 can she make? Can she make 820 remainder 1 groups of 4? No. In this case, we are going to ignore our remainder. We are going to ignore our remainder because I don't care what's left over. I care about how many groups of 4 she can make. So how many groups of 4 can she make? Ms. Fisher can make 820 groups of 4. How did I know it was 820? 800 plus 20 is 820. So I'm going to put that in a sentence off to the side here. Ms. Fisher can make 820 groups of 4. That is my final answer. And so in this case, I completely ignored the remainder. So in other words, we use only the quotient. So if you want to put that in like a cloud or something off to the side, when you ignore the remainder, you use only the quotient. And then color that cloud red. Okay. Can you think of other situations when you would ignore the remainder? I bet you can. Anytime when, here's an example. If I bought like packs of pencils for our class and they're sold in packs of 8, how many packs would I need for our class? Think about that. Would I have any left over? Yeah, well, how many, right? I'm going to have some left over, but I'm not going to break the pencils and give them out and give them in fractions to people. They're just going to get the amount that I have, and I ignore the remainder that I would have. So there's lots of situations when you use only the quotient, okay? The next thing is sometimes instead of ignoring it, you only use the remainder. So number 2 is going to be orange, so skip a couple lines and write 2. Use only the remainder as the answer. So in this case, you would be ignoring the quotient, which is pretty interesting because you do all of that work and then you just ignore the quotient, right? You use only the remainder as the answer. So that is orange. And we are going to write a story problem that is an example of this. Okay. So let's move forward. Let's do a story problem about J.K. Rowling. She's one of my favorite authors. So we're going to say, J.K. Rowling put her Harry Potter wands into boxes. Each box holds 13 wands. She has 719 wands. Wow. The question is, how many wands will not fit into the boxes? J.K. Rowling put her Harry Potter wands into boxes. Each box holds 13 wands. She has 719 wands. How many wands will not fit into the boxes? Let's pick up our orange and try to find the words that would tell us its division. She's putting an amount of boxes. She's putting an amount of wands into boxes. So the fact that she's putting into boxes, she's dividing what she has and putting them into groups, right? Into groups or into boxes. And then it says the word each. Each box holds 13 wands. So you have to take her total and divide it by how many each would hold. And the fact that it says how many will not fit means we have to do all the work, and then we ignore the quotient and go with, well, what was left over that wouldn't go into boxes. So let's do this one in long division, okay? So I have, I'm going to do it over here on the left-hand side. I have 719, and I'm going to be dividing that by 13 because that's how many can go in each box. Okay, will 13 go into 7? No, but it will go into 71. So I put an X above the 7, a little one, and then I go to the 1. And I don't know my 13's times tables very much, so I'm going to use my other skills of double-digit division, which means I'm going to use rounding. So what is 13 really close to? It's either close to like 10 or 20. In this case, it's kind of close to 15. And I can do my 15 times tables, but let's just go with 10 because that's kind of what we've taught before, is to get a number that ends in 0. And let's just see. How many times would 10 go into 71? It would go 7 times, right? That would be 70. But I don't think it's going to be 7 because that's 10 times 7, and I'm going to have to do 13 times 7. So why don't we try 6? Let's light bulb it. I know you love the light bulb. And let's try 6, okay? 13 times 6. See if it gets us close to 71. Oh no, it's too high. Good thing we didn't try 7. That would have been really too high, huh? Well, I guess we've got to drop one down. Let's go 13 times 5. 13 times 5 will work. So it's a 5. And you subtract 65 from 71. Make sure that that leftover is smaller than your divisor. 6 is smaller than 13, so I'm good. And then I bring down the 9, and I start over. 13 goes into 69. Well, look, it goes in 5 times because that we already did that. It's 65. I can't get 13 more. That was too high. So it's 5 times again. That's nice. I didn't have to do any more work. Are there any more numbers to bring down? No. So the answer is 55, remainder 4 is the technical answer, right? So 55, remainder 4. Let's go ahead and just write that. That is what the answer is. But the question says, how many wands will not fit into the boxes? Well, she's going to put, here's what this means, sorry. She's going to have 13 she's going to have, gosh, struggle. She's going to have 55 boxes, and they all have 13 wands in there. But then she's going to have 4 wands that didn't get put in boxes. So in this case, we are going to only use the remainder, right? That's what didn't fit. So there will be 4 wands that won't fit into the boxes. I'm going to write this just down here. there will be 4 wands that won't fit into the boxes. That is my final answer. And I completely ignored the quotient. But I had to work out the quotient, otherwise I wouldn't be able to get my remainder. So it's still important, I just didn't use it for my answer. So here are some times when the phrases will come up when you know you're going to be using only the remainder. Okay, so here are some phrases that we could maybe remind ourselves that might happen. So I'm going to put maybe 5 different phrases that you could look for, and I just put them as bullet points. 5 different phrases that if they come up in a story problem, you know it's division and you're going to look for just the remainder. Okay? Phrases like, how many were extra? Or phrases like, how many were left? Or left out, or things like that. Phrases like, how many remain? Won't fit. And this is an interesting one. How many can they keep for themselves? Because oftentimes when you're talking about division, it's sharing, and then the leftover you just keep for yourself, right? So keep for yourself, maybe. I don't know. Those are all phrases, and those are not all of the phrases. Those are just examples of phrases that might happen. So let's go ahead and just write that off to the side with an orange bracket. Example phrases. It doesn't mean this is all there is going to be. It's just, those are some ideas of how you would know to look for just the remainder. Okay, so far we either ignore it and only use the quotient, or we use only the remainder and we ignore the quotient. So we're doing the opposite, right, in both of those situations. We'll turn the page and we'll find out what the third thing is that you could do with remainders. We're going to be using yellow. Number 3. And I'm going to color that yellow. Do you think you could think about what are some other things we do with these answers? What would maybe be another thing that comes up? Well, what have we learned how to do? We've learned how to convert it into a fraction, right? So that's going to be one thing that might come up. So we're going to use the entire answer. Use the entire answer, quotient and remainder. But this is interesting because what that ends up being, when you take a quotient, which is a whole number, and a remainder, which are pieces or not completed groups, you actually end up with what's called a mixed number. Do you remember that? When we talked about fractions a long time ago, we learned what a mixed number is. And now it's going to feel really easy. But back then, it was really hard for some of you to remember what a mixed number was. So a mixed number has a whole and a fraction, okay? Quotient and remainder. This is a mixed number. So on a test or on an assignment, if it says, what will you do with the remainder? And one of the options says, create a mixed number, that's this one, where you use the entire answer. Okay, I'm just going to go like this and leave that arrow gray. You're going to change it into a mixed number. Okay, so here's an example. We will do a story problem about someone I know. You ready? This person that I know really loves to watch movies. Ready? Her name is Melanie. Melanie wants to watch 489 minutes. Wow. Of Netflix shows over the weekend. That's real life. I want to do it. I don't always get to. Melanie wants to watch, not me, a girl named Melanie, wants to watch 489 minutes of Netflix shows over the weekend. She wants to divide the minutes equally between 12 different chunks of time. How many minutes will each chunk be? I'm going to actually say, how many minutes will each chunk of time be? Pick up your yellow and let's try to find some key phrases in here that would tell me its division, okay? Melanie wants to watch 489 minutes of Netflix shows over the weekend. She wants to divide the minutes equally. Divide. Equally. Between. Those are all division words. 12 different chunks of time. How many minutes will each chunk of time be? So we've got a lot of division clues in here. So I take the 489 and I divide it by 12. Correct? That's correct. And I'm going to find out that I'm going to have a remainder, but I don't just leave those minutes off. I want exactly 489 minutes. So I'm going to have to take the leftover minutes and divide them. I'm going to have to make a fraction of time. Okay? So let's do long division on this one. 489 divided by 12. 12 goes into 48 exactly 4 times. Well, I should slow down. I'm sorry. 12 does not go into 4. So what do I place above the 4? An X. But 12 will go into 48 4 times exactly. Make sure that that is smaller than your divisor. It is. So now bring down the next number. How many times will 12 go into 9? It won't. So 0 up in your quotient line because 12 will not go into 9. So it's a 0 here. What is 12 times 0? It's 0. So if you put a 0 in your quotient line, you're just left with this 9, right? Let's kind of prove that. Well, 12 times 0 is 0. So if I were to subtract it, I still get 9. I can have a remainder of 9 because I can't make another group of 12 out of the 9. So that is a reasonable remainder. So I have 40 remainder 9. But if I'm going to put this, remember like a 4th grader, that doesn't make sense in my story problem. How many minutes will each chunk of time be? 40 remainder 9 minutes? No, we don't talk like that. So each chunk of time is going to be 40 plus a fraction, right? So we're going to take that and we're going to go, well, it's 40, and then 9 is the numerator, 12 is the denominator. So it's 40 minutes and 9/12. Guess what? That can be simplified. So that's another answer. Did you know that you can take 9/12 and divide each one by 3 and you would get 3/4. So another answer is 40 and 3/4. I have 3 different answers here. Which one of these do you think is going to be the correct answer to use when I'm dealing with this story problem? I would say either fraction will work, but we're going to go with the simplified one. And how do I put this in a second? How do I put this in an answer? How many minutes will each chunk of time be? Each chunk of time will be 40 and 3/4 minutes. That's how you're going to have to say that. Which in a minute I want to challenge your thinking and stretch it a little to ask me, well, how many seconds is that? Right? Because normally when we deal with time, we don't say fractions, we say minutes and seconds, but we'll figure that out in a minute. Let's write the answer. How many minutes will each chunk of time be? Each chunk of time will be 40 and 3/4 minutes, which is, and this is where I'm going to challenge you, 40 minutes, because that's what those are the whole minutes, and how many seconds do you think that is? Is it just 3 seconds? No, it can't just be 3 seconds. So you're going to have to figure out, well, how many seconds is 3/4 of a minute? So all you really have to do is think, how many seconds are in a minute? 60, right? So you go like this. This is pretty cool. Let's come over here onto the left. You take your fraction, 3/4, and you're going to be doing a robot voice. So you're saying, how many seconds is 3/4? And because I'm asking for seconds, I use the denominator 60, because we know that there are 60 seconds in a minute. So then you turn on your robot voice, and you know how to do this. How did I get from 4 to 60? Guess what? If we would have left it as 12ths, you'd be asking this question. How did I get from 12 to 60? That was a little easier. You times by 5, right? Well, let's come back here. How did I get from 4 to 60? I timesed by, it's 15. And 3 times 15 is 45. So 3/4 of a minute is actually, well, it's fun to hear the bell, huh? 3/4 of a minute is actually 45 seconds. It's pretty cool. And if that was a little confusing for you, that's okay. You don't have to know that, but it's kind of fun to stretch your thinking a little bit. Let's put this in a circle. We used a mixed number for that answer, and then Ms. Fisher just challenged us there. So number 3 is to use the full answer. You do this a lot when we're talking about like food, like think about a candy bar, right? I can take a candy bar and break it into thirds, and then maybe I have some leftover, because maybe I only am sharing it with one other person, and then I can break that other piece into smaller pieces. So I can break up food pretty easily. I can break up time pretty easily. So you just have to put yourself in a situation to really decide if it's going to work, if that's going to be what you end up doing. Okay? The next thing we're going to learn is pretty interesting. It is going to be taught to you in the next video. So I'll see you next.